Okay, so we'll have a look at question 9 of exercise 7b. So it's about a restaurant owner and her customers, and typically 1/5 choose lasagna. She changes the recipe and she thinks that will change the proportion of customers choosing lasagna. Okay, so we don't actually need to do this. It's worth saying just at this point, she takes a random sample of 25 customers. We don't need to do it at this point, but it's probably worth, just for the whole purpose of the whole question, defining our variable. So if we say x equals the number of customers choosing lasagna, and we'll say x follows a binomial distribution. We've got 25 trials and the probability of success, we'll just for now call it p, and then our null hypothesis is p is equal to 1/5 or 0.2 if you like. We don't need to put this bit in. I'm just I guess probably when you input in your calculator you tend to work in decimals, but it's not a big deal either way. And then h1p is not equal to 1/5, which is the same thing as 0.2. Okay, you don't need both of these. You can just have one or the other. The reason it's a two-tailed test, just notice. So she says she believes the probability will change. She believes the change in recipe will change the proportion of customers choosing lasagna. She doesn't say whether there's going to be more or less. She just believes there's going to be a change. So could be more, could be less. That's what tells you it's a two-tailed test. Right. So we've done part A. We've suggested a model and stated suitable non-alternative hypotheses. She takes a random sample of 25 customers. Find at a 5% level of significance the critical region for a test to check her belief. So we're looking for the critical region at a 5% level. So we're looking two-tailed test for the top 2.5% and the bottom 2.5%. Right, now we can do, fortunately, because 0.2 is a nice probability, we can just use our tables and read it off, and 25 is a nice number. It features in the tables. So if we go to our tables and we want n is 25, I don't have to use my calculator for this. You could use your calculator, no shame in doing that at all. And we're interested in this column here. So if we do the easy end first. Now we want to be in the bottom 2.5%. Now this question I don't think is quite right actually, if you look at the answers and the way they match up. So we want to be in the bottom 2.5%. Now officially, to be in the bottom 2.5%, we would have to be here, because if we're looking at one or fewer successes, then we're only in the bottom 2.74%, which is in the bottom 2.5%. But if you look in the answers and you look in Solution Bank, they have just gone to the nearest, the one that's nearer, because that is a long way from 2.5%. So even though the question didn't word it, they've gone to that. Now I don't think that's right. In an exam, I would expect them to word the question in a way that says go to the nearest 2.5% rather than you must be in the nearest 2.5%, which is what you should otherwise assume. But anyway, we'll go with the answers as they've got it in the book. So let's write down some probabilities. So that was part A. For part B, probability that x is less than or equal to 1 is equal to 0.0274. And the probability that x is less than or equal to 0 is equal to 0.0038, and we're just going to say this is closer to 0.025%, so we're going to go with that being our critical region rather than that, even though the question didn't ask it, but we're kind of saying that the question should have asked it and it would do in an exam. So let's go back. So back to here. Sorry, we've not done the top end, have we? We've done the bottom end. So less than or equal to 1 is the critical region. Let's look at the top end now, and let's find some probabilities. So going back to here, we're interested in the top 2.5%. Now hopefully you can see it's going to be, this is kind of the critical bit around here. So if it's the top 2.5%, 1 minus 2.5% is 97.5%. So we're looking at 0.975, and that's the crossover. Now at this point, I quite like to write my probabilities out because it's really easy to get a bit confused with the inequalities, etc. So if we say the probability that x is less than or equal to 8 is equal to 0.9532. Now that includes 8, so that kind of implies that the probability that x is greater than or equal to 9 is equal to 0.1 minus that, which is 0.0468. So that's not in the top 2.5%. Let's have a look at the next one. The probability that x is less than or equal to 9 is equal to 0.9827, which implies the probability that x is greater than or equal to 10 is equal to 0.0173. So doing 1 minus this amount here. Now, if we're asking which one's closer to 2.5%, this one. So this is closer to 0.025. So our critical region then is greater than or equal to 10 and less than or equal to 1. So hence, critical region is equal to 0.027. Critical region is x is less than or equal to 1 and x is greater than, or x is greater than or equal to 10. Okay, let's just check we've got that right first before we move on. So 7b, question 9, there we go. Critical region is x is less than or equal to 1 and x is greater than or equal to 10. Okay. I think I prefer or rather than and, because it can satisfy this criteria or this criteria rather than and, but I don't think they pick you up on either of those. Right, okay, final question was then the actual level of, oh no, it doesn't word it as the actual level of significance in this, does it? It says state the probability of incorrectly rejecting H0. Now it's only 1 mark and it's the same as the actual significance, but let's just kind of talk a little bit about why that is the actual significance. So there is a 2.74% chance that you'll get 1 or fewer people picking lasagna, even though the actual proportion is still 0.2. So you could get a result as extreme as that, less than or equal to 1, 2.74% of the time, without there being any change at all. And if you got that sort of result, 0 or 1, you would reject the null hypothesis wrongly if the probability truly was 0.2. But you're kind of making the assumption that it's so extreme, it's in the bottom 2.5%, that you don't expect that your assumption of the true proportion choosing lasagna to be 0.2, that assumption can't hold anymore. So you reject it. So yeah, and then similarly at the top end, there is a 1.73% chance of getting 9 or more customers picking lasagna when the proportion of customers actually choosing lasagna is 0.2. But that probability is small enough that you say, I'm not going to hang on to the assumption that the probability really is 0.2. But it could be. So it's just the same as the actual significance. So we're just going to add together, for part C, this probability and this probability. So 0.0274 plus 0.0173 gives us 1. 0.0447. Let's just check we got that right. Yeah, there we go. They're giving it as a percentage, 4.47%. Okay, hope that helps.